Okay, I'm gonna talk in English a little bit. Who's not ready for that, just tell me. Um, I'm gonna tell you why I'm doing this talk in English later on, but you need to know English to start data science. So now, my name is Vadzim Yermakou, but I'll start with simple questions like, do you understand English? Okay. Do you know what data science is? English better. Who works as a data scientist? Anyone here? No, that's bad. Have you heard something about Kaggle ever? Good, at least one, at least two, at least a couple of more guys. And some more there. All right. So let's start. Firstly, a little bit about my background. So I got my major in physics. I graduated from Gomel State University, named after Scarina. Later on, I moved to do second master degree in Europe. It was in molecular dynamics. It was between Rome University and Lyon University. Later on, I got my PhD in England. It was again in physics. It was a bit chemistry and physics. It was in University of Surrey. So generally, I've not been such a good coder. So during my studies, I used to code a little bit. In Europe, I've been coding in Fortran and later on in MATLAB. I never really got into data science. I never heard about it. But I've got some education in physics and maths and statistics. And right now, for the last 8 months, I work as a data scientist or machine learning engineer in Gecon technologies. So that's my current Kaggle profile. So Kaggle profile means that this is a special platform where machine learning contests take place. So since I've started it less than a year ago, you can see I've got a couple of medals. It means there know something about data science at the moment. At the same time, I'm on the platform. This is data science contest from Sberbank that actually takes place right now in Moscow. I think in like half an hour, I'll know what place we've got there, but I know that our team got the top 10 solution out of 300 contesters. So I know something about data science. I haven't been data scientist a year ago. So this talk is about how to get into data science with some personal experience. So why this talk matters? If you Google, something like switch career or how to get into data science, you've got millions of results because currently the market is really, really growing. And there are a lot of people who want to jump into this, right? And I'm going to talk about how I got into this, how you're going to train, how you're going to practice. What is the best way, in my experience, to get some practice in machine learning? So where's machine learning? Let's say it's a mixture of three really different things. One is computer science. So you need to code. You need to write a good code. It's about maths and statistics. So you should know a little bit about mathematics, correlations, and things like that. And it's about business knowledge. So when you work in a particular domain, you should know how the business works. So you need to dive into this because you need to think about the business value of your model all the time. So the data science is basically such a kind of unicorn, right? Who knows all the three things a little bit. He's not super good in any of those, but he's good in everything a little bit. Small example of what data science is. That's really small and simple example. I think all of you use mobile phone, right? Every one of you talk on your phone every day. You send your text messages. You use your data, right? You download, you browse your internet. And the telecom industry has all the information about you. How you talk, how long you talk, whom do you call. So basically, if they go back in the historical data, they can have just a small thing like that for each one of you, and they know how did you behave historically. And if you churn means that you left your current provider, you switch to another provider. In their database, they have a little thing saying true or false, whether you churned historically or not, right? So if they will have this data, they can train a model on historical data. And they'll know that the current person talking this amount of time, sending that many texts, he most likely to churn. So the machine, once it learned, it's basically just an algorithm, just a model. When you apply this model trained on this data on a new unseen data, it will predict who will churn or will not churn, let's say, next month. And this is called binary classification. It's very simple. So we basically classify people by two things, 0 or 1, true or false, churn or not churn. Why it matters? The business value is obvious. It's much cheaper to keep existing customer than attract the new customer. So once the telecom industry will have information that you're going to churn next month, they probably will send you a text message saying, please stay with us, we'll give you discounts, we'll give you free data, we'll give you, I don't know, the free phone with some discounts. So that's how machine learning works. And it actually works every day right now. If you browse in your I don't know, VK at the moment, probably telecom industry watching you, why you do it, and if you're going to churn or not. So that's really simple example how it works. That's the machine learning, how it works, and a lot of people want to switch. Why would you switch? Why would you like to switch? Well, the first thing is, of course, the job market is enormous. This is just a small graph from the headhunters. And if you look at the words at the opening saying machine learning or artificial intelligence in the opening since 2016 up to now, the growth is over 1,000%. So over the course of the last 3 or 4 years, there is a huge market of data scientists, right? The industry really wants data scientists. And that's one of the things why you would like to switch, why you want to switch, because there's a huge job market. Another thing that I want to say that data science is not rocket science. Basically, just the skill you can acquire, and you having a good enough background, you can jump into this pretty quickly. And of course, data science in Gomel will be on the rise too. Well, I don't know the current market really good, but I don't think it's really huge at the moment in Gomel, but it's definitely going to grow. And the data science itself covers quite a lot. So first of all, as I said, it's job opportunities if you want to switch. The second one, it's multi-industry domain. What it means, if you used to work, I don't know, as a doctor, you can go into data science and continue to work as a doctor in data science because it goes to the medical applications as well. If you used to work with the telecom industry, you can switch to data science and work in telecom industry. The same with banks, the same with retail. It really gets everywhere. If you want to switch, you definitely need to have a passion for data, because it all starts with the data. You need to love data. You need to dive and play with the data. And the good thing about it, you can see the impact of your job pretty quick, right? In real business, if your model really got into production, into development, you can see how it brings money pretty quick. It's not always the case, but if it's there, if it works, you'll see the impacts really quick. And it's really nice part of this job. What I need to become a data scientist. So first of all, I really admire you to join the community, even if you just want to know something about data science. It's called Open Data Science Community. It's got more than 20,000 people. It's the biggest Russian-speaking community. And people there can answer a lot of your questions. If you have the questions about the courses, about the models, about the contest, about the job, about DevOps, about data engineering, that's really great community. The second one is, of course, English. I mean, that's why I talk in English. You really need to speak English. You really need to read English because, well, the state of the industry at the moment, that all the new models, all the new talks, all the new discussions are actually in English. You would be forced to read a lot of it in English, including papers, including forums, including current state of the work. So English and open data science is a really great starting point. So what is the typical way of getting into the new field? So the typical way is this way, right? You go to the online courses and you start to read about how to get into this field, right? You read online courses. The best ones are probably Andrew Ng, a very famous guy in data science. Another one is really good course on Coursera made by Yandex. That's actually in Russian. So this is where you can educate yourself about machine learning theory. So you can read about the algorithm, how they work. You can do a little small assignment. There is also the mlcourse.ai, basically developed by my friend from Open Data Science Community. It exists both in Russian and English. It really gives you a really quick introduction. But the problem with all online courses to find the motivation. Most of you work, so you need to allocate some time in your evening. You need to work, you need to study extra, I don't know, 1 hour, 2 hours every day. And it's really difficult. At some point you think, why am I doing that? You know, I've got a job. I'm a developer already for last years. Why would I need to switch? So another way to jump into data science, and from my personal experience and experience from many other guys is really great, is to go onto the Kaggle. So Kaggle is the platform where businesses give you the data and you can play with the machine learning algorithms straight away. The good thing about the Kaggle, so first of all, you have a good problem statement. So the companies do think about what they provide you, what kind of data. They have all the metrics, and all you need to do is just develop nice models. That's just perfect. You start straight away, and if you don't know something, you go back to this theory. But you're really working out and you start to build your model straight away. Another thing is gamification. I'll talk about it a bit later. And as well, a really good thing that the final solution out of Kaggle you can use as your project, right? Once you finish the content, you can put everything on the GitHub as end-to-end solution with a good README, and you can promote your work. And it's always good for your future work because you can use part of your code in your future work, or it's good for your CV, or it's good for your employer. You always can show him how good you are, what kind of codes do you write, what you can do. So where's Kaggle? Let's talk about Kaggle a little bit more. That's just a small reminder how the real project works and how the project works in Kaggle. I will talk about it more later, but now just understanding. So everything in real life work starts with the data. So we've got the data, then we decided we can build a model. You need to go into business understanding and data understanding. You need to understand what kind of data do you have, how sparse it is, how many features do you have. Business understanding, you need to understand the value. Straight away, you need to think, if we build a model based on this data, what kind of value it will bring to the business. Then you prepare your data, you do the modeling, you evaluate it, and you go back. You once again see how good the metrics, do we improve anything? So you go like this a couple of times, and then you go to the deployment and you actually pour it into the real world. So on the Kaggle, you don't have business understanding and you don't have deployment. What you have the data, you have all the metrics, and you have your modeling. So it's quite a narrow field, but it's really great just to train your data science skills in terms of modeling. Why do we need this? I mean, if you want to become a data scientist or you're already data science, it's really great for experience. Let's say there is a new topic, a hot topic like, I don't know, instant segmentation, and you have heard nothing about it. You find the current thing on the Kaggle, you jump into it, you read about it, and you learn really, really quickly. There's a huge community, huge forum, and examples of the code. So it's really nice to learn. In the end of the contents, if you really take a lot of part into this, you have medals, right? So like I've showed my profile, I've got a couple of medals. It shows you that out of 2,000 or 4,000 people, you're in the top 1 solution percent, top 5%, or top 10%. It shows you that you know something. You can always sell yourself to your customer, to your employer, or just put it on your CV. And of course, there is some money, okay, but the money allocation is very limited. In the last Kaggle competition I took part, there were 4,000 teams, and there were only money for the top 5 solutions. So money only go to the best of us, but so don't think about the money really. Why industry needs this? So that's how the Kaggle page looks like of one of the latest competitions made by Avito, which is a big Russian website. So of course, like Avito, they have their own data scientists that work on the problem, and they do develop their own models. So why would they need to go to the Kaggle? The thing is, if you're stuck and if you cannot improve your model and you work so long on the current problem, you don't know something new, and you just go onto the Kaggle, probably the company spend like, I don't know, a couple $100,000, but there would be thousands of people dealing with your problem. So out of this, you're getting new ideas, new instruments, and of course, it's a bit of marketing for Avito, right? Because they show what kinds of problems they have in data science, and maybe they can hire someone who've been taking participation in this challenge. So it's basically a win-win situation, right? So we as a users, we have an experience and medals and things like that, and experience. The company wins out of it because they've got new ideas, new instruments, and they basically improve their models. So they improve their products. That's of an example of how Kaggle works. If you've never been there, if you'll go there right now and you choose one of the competitions, that's how it will look like. So when you go on there, you probably should start here. You should read about the description, which will talk about the problem, the statement, the data, and probably what the company wants to see in the final project. Evaluation, it will be about the metrics, the prizes, the timeline, how long it will take. But then you should probably go into these things here. So the data, it will contain all the data that is provided. The kernels, this is a very good place to start, because the kernels are basically the scripts or a part of a code in the cloud that you can run straight away. The discussions, very helpful for learning, very helpful for developing models, because people really try to bring all the latest papers, all the best and most interesting, relevant information into the forums. So we would need to learn to read a lot in English. The leaderboard, I will talk about it now. Rules and teams. You can unite into teams. There is no necessity to do it all by your own. You can find someone all around the globe who is quite good, who can do the same thing, and you can join together in a team. So it's very easy to start to do the Kaggle. If you're afraid of it, you should not be. You just choose any competition that you think is relevant or more or less easy to join, and you go to the kernels. So in the kernels, it will look like that. And basically, you see here, there will be the score of the model. So these kernels in the cloud, they contain the code, they contain the model. You can look into the code straight away. You can press the button evaluate, and it will, calculate everything in the cloud, and it will do the submission file, and you just submit it. That's the easy way to start. And after you've done it, that's where the gamification kicks in. So there will be a leaderboard showing the score of your model, and you will be somewhere, well, most likely somewhere in the bottom. But straight away, you will want to improve your model. You would want to be better. So you go back to the kernels, you start to look into your code, you start to tune it, you start to add some features, you start to run it, and you'll see yourself going up, 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 up. And it really helps to learn new things. Because then you think, okay, I'm stuck with the ideas, I need to do something new. Then you go to the forums, you read something, you read the paper, you go back to the theory. So it's a really great way into joining the Kaggle. So, real Kaggle example. So that's an example of one of the competitions where I took part. I'll show you how it looks like. So that was done by the Home Credit Bank, the big international bank. And the problem statement was, can you predict how capable each applicant is of repaying the loan? Without going too much into details, basically it was a very similar problem, the one I stated before, like in telecom industry, 0 or 1. So we need to predict out of application, the guy walks into the bank, fills up application and says, I want the credit, I want a loan. So out of this, we need to create the model that will predict based on this information whether he will pay back the money or not. So once again, it's binary classification. They provide you with the data, and once you join the Kaggle, they have an unusual way of evaluating it, so I need to go through this. So you have 3 sets of data. One is called training set. So this is the data that is available to you, on which you train your model. And once you train it and submit your scores, you get your ranking based on a test set, which is public test set. So it gives you the score, gives you how accurate your model is. But to make it more like a real world, right, more like how it would work in real life, they've got a second test set that is not available to you till the very end of the competition. Once the competition is finished, your model will be evaluated on the private test set that has not been seen to you. What it is made for, because you can train your model that good that it would be perfect on this public test set, but on the private it would be complete rubbish. So there are some tools that you will need to incorporate to your model to keep it good and both testing sets. So that's how the data looked like. If you go to the Kaggle and press the data, that's just an example. We've got the customers, the applicants. Of course, it's all anonymized, so we don't have names, we just have numbers. We have the target, so it's basically the historical data, whether they returned the loan or not, so it's 0 or 1 once again. Then we had loads of features, what's called features, so different tables, so the name of the contract, so different loans, the gender, whether they have car or not, and so on and so on. So altogether, it was more than 500 features in this particular contest. And the metric is there. So the metric is there. They provide you with the metric that will evaluate your model. So you don't need to think about it. In real life, it's not true. They think about the business value. You don't need to think about it, all right? It's their problem. They just provide the data. You just do the model. They think about it. It's not your problem. But the good thing, they've done all the dirty job. They prepared the data. They did it. They created the metrics. Your job is to create the model. You know, it's just the pure data science which you can't find in the real life. So once you have this data, you dive in. You dive into the data and you need to plot some things. You need to see the number of entries, the different statistics, the correlations, the relation between the different features. So you plot things like that to really understand the data. You need to dive in a little bit into the business domain. You need to understand what actually banks provide you, what they want out of the customer, out of the applicant, and you need to understand which features are the best to incorporate into your models. That's actually applicable to the real life as well. So in the real life outside the Kaggle, you would need to do it as well when you have the new project. And then you basically start with just the simplest model. In the very ideal world, this basically just simple machine learning model looks like in this particular competition. That's it. That's basically all you need from coding, you know, a couple lines of code. And you start with it, you train it really quickly, you submit, but then you start to improve it. Where I particularly did it, my secret sauce in this competition to become quite successful was feature engineering. So I've been looking into different statistics, financial statistics of the applicants. And if there were non-normal distributions, I hope everyone knows what the normal distribution is. Yes, good. So I've tried to normalize it. So this is non-normal distribution. So if you apply logarithm or square root, you probably will see the normal distribution in the end. Well, it depends really. So I tried to normalize all the data about the financial statistics, and then I tried to incorporate normalized distributions into other features, and that's really helped in my model to become really accurate. Yeah, and in the end, I've got 83rd place out of, I think, nearly 4,000 people, 4,000 teams taking place. Well, it's not that great, but it's not that good, really. But the best takeaway, I've learned a ton of new information, really, really a lot. So you know everything about this particular technique, you know about how to merge them, how to play with the data, what you can do to improve your model. And the most interesting thing, that it's been used in my future work. So the next, I'll talk about it later, how I used in my real work. So once you finish your competition, like I've done here, what you need to do, the best thing is to share your code. Once you finish it, don't forget to clean up your code, to put it on GitHub, to share with the people and share your Kaggle victories. Show people and other guys that you can do it. Why I'm having this screenshot, this is Vladimir, my friend. He works in Lyft in California, but he's very successful in Kaggle. And what he used to do, I think it was only his idea, I'm not sure, but he got PhD in California, and you know, he came from academia, and he used to write after his experiment a small preprint, like a small paper, like they do in academia. So after each Kaggle competition, the ones I've highlighted it here, he started to work to write down a small preprint, share the code, and put it into the academia. Yeah, I think he shared it on archive. But what I want to show here that, okay, this was printed in 2017, this one 2018, and they have already around 20 sightings. So, which means that this platform is basically like a game, okay? You just play there, you just improve your skills. But in reality, it's getting so good that in academia, in the real research, they do use these results. So this means that 20 people from the universities cited his paper, and this paper been cited whatever 16 times. So what I want to say is that Kaggle is not everything. It's not the best place to get into this data science, and it's not maybe the best place to improve your skills. But once you do it, you can do it. If you do it right, it can be used even in the real data science research. How to be able to do everything? Well, that's difficult because, I have 8-hour job, and after that, coming back home, I need to work on Kaggle for another 2-3 hours to become better. So I think you just always need to have a plan. You have to understand why you're doing that and what you're getting out of this. Always study little by little. It's not just about the studies, it's about your models. Once you have a simple model, just try to improve it day by day. Just every day, improve your model by a little bit. And, within the 3 months course, like how long will take the Kaggle competition, your model will be really good. And Kaggle helps really a lot, but don't forget to stop, because Kaggle is not real life. It helps you to gain knowledge and power and new information in particular field, but it's not everything. So the real world example. So now I'll show you how the competition I took part in Kaggle helped me in my real world and what was different. So the customer from UK came to us and said that they need to predict churn. And I said, okay, guys, that's easy. I've been on Kaggle. I got 83rd place. Easy. Give me 2 weeks. And but I forgot that in Kaggle you don't have business understanding and and deployment and data, but it all starts with the data. And it turns out that because of the GDPR, do you know what GDPR? This is the European law of data protection. Because the information is so sensitive and there are so many restrictions, they couldn't share data with us before our lawyers and their lawyers sat together and they had to create the new rules for their application that would be pushed to all the users, and every one user had to accept it. And basically we had a pause for 2 months after the kick-off of the project. So that's the real world, and it's not Kaggle. So just to have access to the data, we had to wait for 2 months. That's ridiculous, really. Then when we actually got the data, I said, okay, now I really will do it in 2 weeks. Okay, on Kaggle, I'm really good. Let's do it. But on Kaggle, on these contents, on this competition, I had 500 features, which was easy, Even small model with 500 features would converge really easily. But on their data, we had 25 features. And when I started to dig in and we started to clean the data, in the end, we finished up with 14 features. So 14 and 500 is a huge difference. So we had to create another simpler model, actually, that would work on so many features. But then in our project, we had 2 data scientists within the UK team and 2 data scientists in Minsk. And we started to work really, really great. The guys in UK been developing neural networks. I've been working on this binary classification. And we've been doing it for like 2 weeks. We created some models, and then we realized that we don't know what is churn in this case. Okay, in telecom industry, it's easy. The guy leaves the network, it's churn. Okay, he left. And this was an app where you could invest your money. So you put your money on your account, you press the button, and the system itself will, invest your money. So what is churn in this case? If the guy didn't put the money, or whether he withdrew the money, or whether he didn't use the application for 2 months. So we actually we had to go back a little bit, and we had to talk back to other guys what actually is churn, what they define as a churn. And the other thing is, when we defined what the churn is, we've created the model, and we were so happy with them, had accuracy, whatever, 80%. We thought it's super good. Now the company will be happy. But it turned out that, in Kaggle, you don't think about it. You've created the model. It's their problem. In this case, the end user was their financial department. They didn't care about models. They didn't care about accuracy. They didn't care about that. All they wanted, once in a month, the list of the people that would churn next month. So they didn't care about our job. We were so, focused on the accuracy, but in the end, we probably could develop everything with the simple heuristics without even the modeling. So the takeout of this slide is, the real life is not Kaggle. It does help you, but in the real life, it's a little bit more difficult. So the end of the story, we actually created 3 models. The reason why we've created 3 different models, because they all were based on a little bit different ideas. One was created with the time series, another was created on the monthly basis. And in the end, all of them right now are actually working, and we will evaluate which one of them best by the end of the Christmas. So the way we've created them, we couldn't create these metrics, this extra data where we could evaluate it. So we had just to, put the models in real life for 2 months and wait till it will be ready, what the results will be. So if you're going to switch, and if you want to switch, how long it will take you? Now, this really depends on your background. If you're currently a developer and you've been working as a developer for the last 5 years and you have your major in physics or maths on, econometrics, that probably will be really easy, because all you need, just go to the machine learning theory, listen to a couple of courses, and you will be ready. If you don't have coding experience, you would need firstly to take the Python course or the R course. Probably then you would need to go to the math and statistics. So it will take you about 3 to 6 months to be on the entry level. And just some really quick final remarks. That was said in the interview by Dr. Ian Goodfellow. He's currently a researcher in Google Research. But when he was doing his PhD with Andrew Ng, which is a very famous guy, Andrew used to tell him all the time that you should work on the basics, because you really need to have basics. But Ian thought that it's so boring, I need to work with the best algorithm, I need to work the best papers. But now Ian, when he became researcher at Google himself, now he thinks that it was definitely correct. What you should think about it, okay, you can be the most clever guy, you probably could read all the best and the most latest papers, you could read all the latest algorithm, but if you cannot program a simple, clean code, then you probably will be stuck with this problem, because you need to know the basics, you master your Python code. And just a couple of links. The first one is a really good data science plan that was written in 2017. If you want to jump in, if you want to read a little bit about it, you basically just read through what the courses are recommended there. Depending on your background, you just can take part of it and try to follow it. The nice article written by one of the Open Data Science members, it's called How to Kaggle. It's good introductory to what the Kaggle about is. It's really nice text, because the guy really participated in Kaggle for the last 3 years, and these guys knows a lot about it, how to develop the model, how to stack them, how to win, how to gain new knowledge. And some success stories. This is also in Russian. It's about one of the guys who actually got the really nice job in Minsk as the deep learning developer, but he started his career on the Kaggle and the Top Coder, the second site for coding. So basically he got this offer, and he's been known through the Kaggle. So he became really nice in Kaggle, and then he's got an offer for this nice company. That probably would be really nice for finding motivation to join in Kaggle and try to develop your first model. So that's pretty it. Thank you for your attention, and I'm ready for your questions.